Another type of magnet or magnetic field you're probably familiar with is the magnetic field of the Earth. So Earth has a magnetic field, and the magnetic field is defined based on a compass. So when we say a compass points north, we say that's pointing towards our north geographic pole, but as we said, that opposites attract. So the north pole of a magnet is attracted to the south pole of what we call the magnet inside the Earth. So the magnet inside the Earth is not strictly bar-shaped. In the very simplest models, it is. So the south pole of the Earth's magnetic pole corresponds to the geographic north pole of the Earth. And the difference is that here is our geographic north pole. This is the axis about which the Earth spins, whereas this is the location of the magnetic pole, and it has been drifting towards Russia out of Canada for the last, ever since we've been measuring it, since 1900. And it's moved quite a ways, and it'll probably end up in northern Siberia somewhere. And scientists don't know exactly why this is happening, because we don't know exactly what creates the magnetic field in the Earth. It is suspected that there are currents of iron rivers of lava flowing in the Earth's mantle and its core, and that is what's creating the magnetic field. But we don't know for certain because we can't go there and look. So the Earth's magnetic field is basically, we can model it as a huge bar magnet, but that is not strictly the case. There are disturbances in the magnetic field, so sometimes it does weird things on the surface, and we'll look at some of those pictures. But the magnetic field of the Earth protects and distorts the solar winds, so that as material is being blown off the sun, it doesn't strike the Earth. The most dangerous materials don't strike the Earth directly, but are directed away from us, and we form a little tail. So here is your magnetic declination. Declination is the angular deviation of a compass needle from true north. And so here in Iowa, the compass needles point not quite north, but just a little bit to the northwest. In the central part of the country, like if you were in Nebraska, you would get to a point where the magnetic field does point straight north. But out here in the Pacific Ocean, there are some places where the magnetic field points straight east. And out here in the Atlantic, there are some places where the magnetic field points straight west. So if you were using a magnet, a compass out in those areas, you would need to take that into account. And if you ever have a car that has a compass in it, they'll often ask you where you are or where you're planning to travel, and to change the compass declination based on your geography, because clearly if you're out in California, then we have a different declination than we do here in Iowa, and we need to make a different correction in order for that compass to read correctly. Runways are given numbers based on the direction of the compass, and so at O'Hare, the 14L32R runway means it's 140 degrees, which is southeast direction, or 320 degrees. They basically have just dropped off the zero on these values, just because you only can put two numbers on the runway. But as the Earth's magnetic field, the magnetic pole moves, the lines are shifting some, and Tampa's runway 18R 36L was redesignated 19R back in 2011 because of the shift of the magnetic field. So here's a question for you. What magnetic pole is at Earth's geographic north pole? So this is the North Pole, what we call the north. What magnetic pole is up there? So think about it for a second. Okay, hopefully you figured out that that is, if we put a bar magnet in here, that is the South Pole, and this is the North Pole as indicated by this part of the picture.